Okay, Tim Cook, I flipped the camera, started a brand new video. Okay, this is for all the heads. So now this is me not having slogged through the manual yet. The manual is incidentally called Manual 1 by Frap Tools, and they just keep, I guess, making updates to the one manual, Manual 1. Uh, um, carrier and modulator, in quotation marks. Both are hard normaled to one another. Right there, it's yellow, and right there, it's green. But of course, all these things are interrupted. Unless, I mean, if you interrupt them, then they interrupt. In other words, right? So, for some reason, this frequency input with 2 or 3 CV sources is like the G spot of the unit. Roughly the experience of this interesting device is the fact that it almost behaves like a sequencer. It's like a phase offset sequencer. And it's this and in the way that it happens, I mean, typically what I'll be doing is I'll leave both main dials at lowest frequency or thereabouts, probably misaligned a little bit for different cycle lengths. And start with everything, the attenuators, whatever, more or less. In some reasonable zone. Then what happens is these almost act like pitch dials, these 3. This one feels more like it acts like a kind of amplifier, but also a pitch, like a position. They all act like their phase position offsets also. And then they all attenuvert. And this, okay, the significance, that's an output. These are inputs. These are all outputs. It's what, 2 oscillators, right? It's 2 oscillators. And you've got these waveforms. So the idea is all the like lightning rapid fast percussion avalanche idea is mostly taking one of these carrier outputs stacked and jamming that pitch. So you've got like a 4 or 5 part complex CV going all into this pitch. Then quite often it just sounds like a kitchen bomb of the kitchen sink bomb. And once then you start fiddling with these and it starts creating separation between different sounds, then transients emerge, and you can actually, it's then over here, this is like, this is a filter. It's just a low pass filter. And this behaves like a high pass filter. But this is all like wave folding through zero stuff. I don't know. And then, so these are inputs. These are outputs. These are inputs. These are outputs. Okay, so on that, all that hyper percussive stuff I was doing, I was just basically using this plus that dope for A111-3, which is a VCO LFO that has it has like hard sync, it has pulse width modulation, it has an FM input, etc. And so you can restart the phase with that. With the if you're syncing it with a square wave, and every time that thing syncs, and the sync not even necessarily synced with this. I haven't really experimented with this yet, but when those LFOs all get to battling one another and they're going into these inputs, then all of this creates the separation between transients like I explained. However, and this is a very long-winded way of getting in my 8-minute way of getting to my point, is, anybody that has thought very much about modular synthesis one of their first intuitions about this machine is like, oh, okay, well, what you're going to do is you understand that all of these waveforms are that's like your stack, right? It's just one big wave, it's like, it's a six layers, right, of 6 different waveforms. And then this one has a switch on it too. So, so clearly what one wants is to take the signals out of here and get them in, get them going through something else for further processing, right? Okay. So now we're moving from intuition to plan, right? Because this is really the first time that I've carefully, it's like eating your vegetables, right? You always fall for the intuitions because it's fun to crank knobs, but all you're going to get is, it's not going to go anywhere. You get some interesting moments, but then, it winds up being kind of the it's not very efficient. What's the diminishing returns is what they call it. So I'm reversing the diminishing returns on this box right now by tapping the oscillator before anything processes it inside the box. So forget about this, because the final, that's actually going to the final mix out. This is like the end product signal. This is the only thing that's going to be happening when I turn the sound up in a second. So here we've got this saw wave, and it goes, I just wanted to do something simple, but even simple with modular synthesis is like already you have a plate of spaghetti in front of you. So this is going to go what? So I'm going to tell you the plan first before everything gets confused. I can confuse myself. So this oscillator, or this signal, this sawtooth wave, all that's going to happen is it's going to go into a VCA, an external VCA, and I've got, so the VCA is just a dope for A130, and then so that's the where the green's plugged. And then in CV2, we've got a single voltage that's coming from, what's it coming from? It's, I think, without looking, it's a Pittsburgh modular ADSR envelope. Kind of, where am I? Gosh, it's hard to line this up. Oh, yeah. Yeah, so these Pittsburgh envelopes, they seem like they're designed more for like live performance, rather than like studio precision. Whatever. Regardless, the intended usage, all that an envelope generator is a voltage with a start point. We're not going to talk about envelope generators right now. Okay, so that's coming out of the envelope, but that's what makes, anybody listening to this knows what an envelope generator is. Sorry for wasting your time. I'm not wasting your time, don't worry. Because this, it's none of this, because it's so easy to make mistakes, careless mistakes. Every step of the way you can make a mistake, and then you wonder what the hell you did and why you're not hearing something. Okay, so the Pittsburgh envelope is controlling the A130 VCA. And then this BFACO ADSR is being triggered by this LFO. So the envelopes are really unrelated. Is that right? Let's see. One's triggered by this A146, and the other one is what? Is being triggered by the BFACO sustained gate out. Okay, so the Pittsburgh is being triggered by the BFACO sustained gate out, and the LFO is driving them both, right? So then the BFACO is going into this diode low pass VCF, and the Pittsburgh modular output is controlling that A130 VCA. So the only signal we've got going in is that, and that, because I just replaced that one, and now I have to get going into the A102. I want another signal like that one. So probably one from the carrier wave with the switch on it, which I haven't looked up yet. I guess it was a polarity switch, but then has little details that makes me wonder. Okay. Okay, so oh no, I was going to do this. Yeah, that's the other thing, forgetting which jack, I mean, what the idea is as you're doing it. Or even, like you're playing telephone game with yourself. But by the time you get all the cables connected, you at some point along the process, you start interpreting a different concept. And so, like, instead of the clock outputs, you're taking like the audio outputs or something like that, and you're thinking you're taking the clock outputs or whatever. It's just the syllogism of it all. If such and such and such and such is such and such as such as such, then such and such and such and such. That's happening every step of the fucking way. And syllogisms are deceptive, because on the one hand it's simple, but on the other hand it's easy to make mistakes. Yeah, simple, deceptive simplicity, or whatever. I guess that's real. Okay. All right, so that one's going into this. The diode low pass. Now, that's processing the sawtooth wave. No, that's that square wave with the switch on it. And That's the sawtooth wave. Okay. So the LFO is triggering, that's the only gate that's triggering both envelopes. The sustained gate out of the one is triggering the other one. So really, both of them just depend on one single gate here from here. It's so funny how Tim Cook doesn't focus its camera. Why is it? Maybe is it the sound? No. I guess it's focused now. What did I say? Tim Cook doesn't focus its camera. That sounds about current. Okay, so that one distorts the square wave, so we get onsets at, soft attack, hard attack onset. Or no, that's yeah. So you make saw waves, I guess, right? Yeah. But that makes a square wave because the top is a square. Okay, there we go. Okay, so that's going into this, and as it hits the sustain right there, that one triggers this. That was that sustain. So you can actually see them both operate. Yep. Okay. And then that's the diode low pass. The level is almost nothing. Now all this, I've got levels down on these. Tim Cook is making focus very difficult of the camera. Okay, so that's the bulk of it. Really, everything happening with this patch, it was like, it's like 80% planning. The whole thing took a couple hours to set up because I replaced the audio. First, I used more different oscillators. I didn't use the oscillators coming out of the box. And then I remembered, no, come on. Dimitri. The whole idea is to sequence the waveforms independently coming out of here and then get them going back in. This is coming from, oh, and then no, this is the other part. This is the other part. So this thing is like Fraptool's special multiples. And I forget the equations and whatever, like, but suffice it to say, like, it's super deluxe and it's super precise. So you've got the signals coming back from those two VCAs here and here. So that those two VCAs, they're being sequenced. They're being their outputs is coming back here and being buffered and conditioned properly, like an adult. And then that was a joke, by the way. And then yeah, that's coming. These are coming from across the way, like from over there. And then these are the outputs. It's a bit counterintuitive. So the input, no, it's not. Then the outputs are here, and these go back into the unit, and then we can say it's as though nothing happened. For all the unit knows, it's just dealing with its own internal sounds, except you've hijacked them, sequenced them, and then put them back, acting like nothing's happened. Okay, now let me see if I can get the formerly described sequencing transients effect. Okay, so this attenuverts Now, obviously, I need to understand the function of these better, because up until now, it's literally just been a lot of experimenting. Okay, I just put one of I put the LFO that's generating the gate for the envelopes to 0. Well, I mean, not to zero, but much lower than it was. Correct. Quod erat demonstrandum, which was to be proved.